I'll do for just one. So if it is oxygen 816, then what is the atomic number of oxygen?
It's 4.
So this 8 is the atomic number, right? And 16 is what? The mass number. So what's the number of protons in oxygen atom? 8. It's simple, right? So this is 8, this is 16, this is 8. What's the number of neutrons? Okay, 16 minus 8. 16 minus 8 is 8. And what's the number of electrons? 8, because it's just the number of protons. It's 8. Okay? 6, 12, same thing. Now, do it for 11, 23. So 11 protons, 12 neutrons, and 12 and 11 protons. It's very simple, right? Now, this will become important because the only magic that happens is here. So we need to understand where these 11 electrons are going, or how are they getting arranged in an atom in the shell. Okay? Now, okay, let's go with the concept of isotopes, isotones before we go to electronic configuration. I'm trying to be more like organized with a flow, but these concepts are so interconnected that the board reflects the interconnected. It's not that linear. So I'm like trying to be more presentable on the board, but if you are having a hard time following it, that's why I'm like recording the videos so that if you get confused or something, you can just go back. Okay, the concept of isotopes. How I'm sure people have heard about the term isotopes. How many of you have heard about the term isotones? No one? Okay. Isobars. What does iso means? Iso, this term. It will come again and again. Even solution chemistry uses this. Like, I'm trying to like come up with an example of a daily life kind of like a example. Is something coming to mind that we use iso?
Same.
Sorry?
Same.
It does mean same, right? So iso means same. And it becomes easier when you just focus on this one is easy. Isotope means same number of protons. That's it. Focus on the P. If you get confused between isotope, isotone, and isobars, just focus on the P. This means, as Jocelyn said, iso means same, and P means same protons. What is N? Take a guess. Neutrons. So same number, same neutrons. So this is a relationship. This is a relationship. A relationship is between two entities, right? It's between two entities. If I have a sister, I need to have another person. I cannot be sister or brother to myself. So it's a relationship, it's isotope. So you need two people or two entities which have the same number of protons. If they have the same number of protons, they become isotopes of each other. I have a brother. That relationship is like brother, and he's my brother. You get the idea. So you need two entities or more than two entities for them to form a relationship. Same neutrons, isobars. We had an A somewhere. So this is Z. What was A? The mass number, right? Right, yeah. So this. So same mass number. Isoelectronic. It's very easy. Take a guess.
Like the Trump configuration? Or is it just electrons?
Same electrons. It's very easy. Let's go from here. Same electrons. Now, Na. How many electrons do you have? So this is 1123. Now, try and remember as many elements. So I know probably when you were in high school and things like that, people might have told you to remember. In India, so I used to remember things like, so I kind of have it remembered till 36, and then in the next class, just trying to impress how cool I am, I'll just try to remember the entire periodic table. But I know till 36, I just remember it. So I just have like a small song in my head going on, and I do it. So I just do it. So hydrogen and helium is easy. And then I do Libe Baknofne. So Libe Baknofne. And then I do Namagal Sipsakal. So NAMGALSIPS. So Namagal Sipsakal is what I remember in my head as one word. And then argon, potassium, calcium. So this is till 20. This is how I remember. And then I do Skati Vakar Manfeko Ni Kuzan Gage Asse Barkar. So this is 36. I'm not going to do this for you because, you know, in India, these words are really easy for me to say and for Indian people to pick it up. It might not be the same for you. So I generally used to teach my students in India this kind of thing. It's very fun. Within like a few minutes, if you just use this like Skati Vakar Manfeko Ni Kuzan Gage Asse Barkar. So you have till 36. And you can do the same thing for other periods too. So La Haftavareos Irpatauhak, so something like that. Or for 16 group Osse Tepo. So you'll see my Indian accent coming out, right? So you need that thing. So whatever you feel, and I do the American accent to make it more easier for you guys. So when I talk to my Indian friends, I talk in an Indian accent, which sounds like something like this. And when I talk to Americans, I sound something like this. So I just try, because it's easier to communicate, right? So, okay. So what was I? So remembering the names and like atomic numbers, it's very easy. Do it and you will have fun. Like iron is you just count from 21. Skirti, Vakar, Manfe. So like it's 26, something like that. So it becomes very fun. So sodium. So how many electrons? So let's just focus on the electrons right now because we are talking about isoelectronic. How many electrons? 11. So if you do Na plus, what does that mean? 10. Can you guess, can you come up with an isoelectronic 2Na plus which has 10 electrons? Think about here somewhere. So this is 9, this is 10. So neon becomes an isoelectronic species 2Na plus. Why? Because Na plus has 10 electrons, neon has 10 electrons. Okay? F minus 10 electrons. O2 minus. N3 minus. It's nothing special. It's just the same number of electrons. Okay. Let's do isotopes. Can you tell me, give me an example of isotopes where the number of protons remains the same, but you cannot just say 816 and 816 because these two are the same.
It would be like 8 and 17.
Yeah. 817, 18, right? Hydrogen, 1, 1, 1, 2. So protium, deuterium, tritium, 1, 3. Number of protons, same. Number of neutrons, different. Isotopes of hydrogen, chlorine, sulfur, the list goes on. You get the idea. So these are, you cannot say 16 and 16 because I cannot be my own brother. Isotones, same neutrons. And mass number, same. Give examples. And then you are almost free to go. You have to play with some, so get any, let's do this, same mass number. So if you have, argon has a 40. Potassium can have an isotope which is K40. But generally, what is potassium? What's the atomic number? 19? 39? What are these? What is the relationship? They're isotopes because there's both. It's easy to see because you don't even have to write this. You can just write K39 and K40 because K is very much tied to its atomic number. You cannot have a K if it's not 19. You cannot have an O if it's not 8. You cannot have an Cl if it's not 17. But you can have a K39, a K40, because the number of protons is 19, and the number of protons is the identity. Nothing else is the identity of an element. It's just the atomic number. The proton numbers must remain the same. The neutrons here are varying, right? So 20 protons, 19, 39, 21 protons. Okay? So K40 is an isotope of K39, and K40 and argon 40 become isobars. The same number of mass number. Same number of neutrons, a little bit math you'll have to do. I have got an example. Chlorine 37 and potassium 39. Chlorine 37, potassium 39. So you need to know the atomic number. So we know this. What is chlorine? 17. So number of neutrons is the same, 20. Right? So they become isotones. These are isotones of each other. Okay? So you got this understanding. Now, remember I asked a question, how can you get chlorine 35.5? The next class, you'll have to tell me why you have 35.5. It has to do with the isotopes, and it has to do with a concept called natural abundance. Okay? So that's there. The electronic configuration, what I'll ask you to do is then, because I was not able to get it, so this was chapter 6, I think chapter 5, 6, and 7, if you go through the videos, you'll be able to understand electronic configuration. And then we'll discuss the problems, or we'll do some examples of the same. Okay? Cool. Thank you so much.
Thank you for allowing me to learn.
Oh, no, absolutely. Thank you for coming and listening. Sorry.